Hi, and welcome to day 18 of the advent of compiler optimization. We're going to continue looking into inlining today. I'm going to start by writing a calculation function. So let's have unsigned calculate, and it takes an unsigned value x. And this is a completely made up calculation, but hopefully you can see that there is some kind of shades of something that you've written before now. So I'm going to say there are kind of two different things that can happen inside this calculation. There's kind of a cheap and quick answer, and then there's a much more complicated answer. So I'm going to say if x is less than 100, this is simulating the quick case. Let's just return x times 2. Right, so we're assuming that that happens with some frequency. Otherwise, I've got a little bit of extra work to do here, which I'm going to paste in from my notes. And we're going to fix the indentation because it really annoys me. And we're going to return result percent 100, something like that. So we've got a slightly more expensive, let's call this x. Sorry, in my notes it was called value. Whoops, and I've pressed the wrong button. So now we've got the cheap case and the expensive case. This calculate function just compares EDI with 99. If it's below or equal, then we go to L5 where we do the really cheap thing. Otherwise, we've got all these multiplies and shifts and all that kind of thing that's we're using as a proxy for expensive work. It's not, real work, but it's expensive. So what if we wrote another unsigned calc2, unsigned x, and we returned calculate of x? Well, either it'll jump straight to calculate or it will inline the whole function, and it has indeed inlined the whole function. Now, I'm going to have to cheat a little bit here. And so in order to show the kind of thing that the compiler can do more generally with this small of an amount of code, I'm going to add an extra flag, which on its face seems a little bit weird. So bear with me. I'm going to go up here and I'm going to actually tell it to do no inline functions, which you would think would stop GCC from doing any function inlining, but as you can see, it has not. We're still inlining the entirety of that function. It turns off one of the many places inside GCC where inlining happens, and with certain larger functions and larger programs and more complicated work, the compiler may choose not to do inlining at this stage, and that's what I am simulating by putting this flag in. Because what I want to do is I want to make calc2 actually call calculate twice. So we're going to say calculate of x plus calculate of x plus 1. Now, what's happened is that calc2 is no longer inlining all of calculate. It would have to have inlined it twice in order to get the benefit of inlining. Now we're calling it twice, so it has chosen not to do that. But what it has done is rather clever. Let's take a look. So calc2 is passed one value, and the first thing it says is it has inlined that check. If you remember, we've got that check at the beginning of the function if x is less than 100, and we do a much quicker just doubling of x. So it is, if it's below, we go to L13, and there is our doubling of the first value. And then now we're getting the second value, and we're saying is the second value bigger than 99? And if not, it falls through to this case. And so if x and x plus 1 are both less than 100, we've inlined the work. That fast path at the top of the calculate function has been inlined, and so we see it down here where we double x and then we double x plus 1, we add them together and we're done. Otherwise, we fall back to calling calculate, but not the full version of calculate. You'll notice it has this .part.0 at the end. So what has happened up the top here is calculate has been broken into two pieces now. There is the bit at the beginning, the fast path, and then there is the slow path part at the bottom, the unsigned shifts and multiplies and all that good stuff. And so two things have happened. First, the compiler has done something called function outlining, which is where it pulls apart a function into things it thinks of common and fast and cheap, and the rest of the function. Then it can do various types of outlining. But here it's broken calculate into two pieces, and it has to continue to break calculate into two pieces because someone else that's not in this translation unit might be calling calculate themselves. We can't just get rid of the fast pass case because we're accounting for it below. So if you call calculate from another function, outside of this translation unit, you'll get this version where it does the comparison and the LEA, and then it jumps to the rest of the function. But in this case down the bottom, where we have access to the body of the calculate function and we can do the check ourselves, we can inline just the fast part of the function and then delegate to the slow part if we have to. So we can inline the fast part of the function and then call out to the remaining part, the sort of outlined part of the function if the inlining part needs it. That wasn't a great explanation, was it? Hopefully you get the idea of what I'm saying here, and that is the compiler is sort of making a bet here that it's worth inlining that first part of the function and taking the hit of copying it twice, in this instance because we're calling calculate twice, and the performance benefit of doing that is worthwhile compared to just calling the function calculate unconditionally twice. This kind of partial inlining can be really, really handy. I've seen it happen a lot with things like log functions, where the very first line of every log function is something like, if log level is less than, debug or whatever, then return. And so oftentimes if your logging function is more complicated and has lots of prints and formatting and things like that, you'll see that all of the places that call your log functions will actually outline the check, and then the check will be inlined in all the places where you're calling logger.log. And so the compiler has just done the check in multiple places, and it's thought that that's worthwhile doing before it then jumps off to do the log only if the logs are enabled. We'll continue the theme of functions tomorrow. I hope to see you then.